All right, so there is such a thing known as a null pointer. So if we're going to create a default variable, we're going to use a null pointer. So it's basically a pointer where it doesn't do anything. It's just basically we're like reserving space that we're going to use later. So like up to now, we've even been using pointers, but we've then sort of turned around and then like filled them immediately. If you're going to create a program where you're going to ask the user of the program to input like lots of data and it's kind of open-ended, like they may give you 10 things or 20 things or whatever, then what you can do is you can make yourself a null pointer. And so you're basically like reserving a spot and then you'll just fill it at a later time. So it doesn't point to a usable memory location. Instead, it's just a special value that the program can check when no value is needed. Pointers, fun fact, the reason why I said earlier, most of the time you might just want to stick with vectors unless you're doing something like really fancy. Pointers can cause lots of errors in program. Usually we'll allocate memory with something new, send it to a pointer. There's now a chunk of memory on the heap. Everything's okay so far. Then we do the same thing, but we end up assigning something to the same pointer. And so then as a result, the reference to the first object is totally lost. So basically, you have two different pointers that point to the same thing. Or no, you have the same pointer pointing to two different things. And then basically the second pointer you make is going to stay there. And then any way to retrieve the original box the first time you did the pointer, you basically can't reach that anymore. It's like completely cut off now at this point, which is a bit of a problem. So the memory is still going to be allocated though. So the computer will still set aside that memory and it's like not going to let anybody touch it. But then it's like, oh, now you can't access it. It's still there, but you can't access it. I have a sneaking suspicion that this phenomenon is essentially what's at play when, the best way to deal with computer problems is to turn it off and then turn it back on. Because I think it's essentially grander versions of this problem. Because there's memory set aside, but for whatever reason, the computer has kept allocating things to the point that it can't access parts of its memory anymore, probably because there's too many stinking cookies for whatever it is you've been looking at. And then eventually you're just like, all right, just shut the whole thing down. I got to do a hard reset. And now all the memory's back. Hooray. So anyway, that's called, the term for that's a memory leak. So multiple pointers can cause problems. Several pointers might point to the same address. One pointer might make an unintended modification, and then it'll mess up all of them, because as we saw, when you changed Y, it changed X along with it. And then if you screw up and change Y, fun fact, everything else it points to, like if you did A through X, and they all pointed to Y, you change Y, and then whoop, all of them are, Z will still be okay. Let's see. You can point to an object with one pointer only to delete it with a different pointer. And now those pointers point to free space that could contain anything. So you could accidentally delete the pointer that you needed, and now there's no way to, I mean, who knows where the pointer is gone, so who knows what address it's going to go to. So pointer mistakes are very easy to make, and debugging pointer errors is not fun. All right, so anyway, there's a reason why we're basically just going to do a test on this topic, but not actually try to code stuff, because, oh, Nelly, cleaning that stuff up is not fun. So anyway, when reading in an unknown amount of data, or if we need lots of memory beyond what the operating system provides on the stack, pointers will be needed. So if you need like lots of memory, then you kind of probably need to break out the pointers. Like this is beyond what the operating system. So it's like, I'm sorry, Windows, but what you're giving me is not going to cut it. I need more memory. Like that's like, you're doing some high octane mainframe stuff there. If the memory they're giving you is not going to cut it. All righty, so.